And we are now recording. Let me share the screen. All right, so we're moving along. 5.2. So I hope to do most of 5.2 today. So we have some extra days, I think. If I go according to the schedule, we'll have almost a week left, so to speak. In that being the case, I may give you one of those quote unquote longer quizzes, which might take almost the whole period, something which I may not let you give the whole thing on a test, but I might be willing to do on a quiz, right? And again, it's going to set the last exam as Thursday the 20th, not Friday, Thursday the 20th, so that I have one day to make final remarks and review for the final. Although if I finish early enough, I may start reviewing for the final somewhere here. Okay, again, Wednesday the 19th, I'll reserve for questions and answers as normal the day before the test. Okay. All right, so I was going to go back and do just about a bunch of 5.2 questions. We did some yesterday, and I'll do many or almost all of them for today. Okay, so here we go. So let's finish up problem 6 from last time. Okay, so we were looking at this. Okay, and in the in-class, I was asking you what the midpoints are. There had to be 6 of them. Okay, and they were basically at the 0.5 marks. So if you can ignore temporarily the F, the answer to yesterday's in-class should have been negative 1.5, negative 0.5. There should be a negative there, sorry. Negative 1.5, negative 0.5, positive 0.5, 1.5, 2.5, and 3.5. Okay, so those are the midpoints. The reason why I put the F's there is because we need to get the heights from all of them. Okay, so part A, the right endpoints, that will be the function values at negative 1, 0, 1, 2, 3, and 4. So R6 is delta X, which is 1. It's always easy to multiply by 1. And then the function values at the right endpoints that I just mentioned. Again, this would be better demonstrated if we were meeting face-to-face in class. I would project this and then use the whiteboard, but since I can't do that, I have to bounce back and forth. So the right endpoints that I mentioned were negative 1, 0, 1, 2, 3, and 4. Okay, and these are those heights. These are the heights at negative 1, 0, 1, 2, 3, and 4. Okay, so let's see if I can do this. So negative 1 is down here, negative 1.5. Keep in mind, for this funny graph, each square is actually a half. See how this is 1, right? So that's actually 0.5. And likewise, this is 0.5. So that's 3 squares down. That's negative 1.5. F of 0 is 0. F of 1 is 1.5. F of 2 is 0.5. F of 3 is negative 1. That's 2 squares down. It's negative 1. And then F of 4, 1, 2, 3 is 0.5. Okay, that comes out to be 0. Notice that negative 1.5 cancels that positive 1.5. And 0.5 plus 0.5 is 1. That cancels that negative 1. So the answer is 0. Okay, L6. Okay, so what's L, R, and M? L is using left endpoints, R is right endpoints, M is midpoints. The 6 means you're chopping it up into 6 pieces. That's your N. Okay, so the left endpoints are negative 2, negative 1, 0, 1, 2, and 3. Okay, concept again. Here are the subintervals. The length is 1. There to there, 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 there to there. I just did all the right endpoints, part A. Now the left endpoints. So this is negative 2, this is negative 1. What's the left endpoint? Negative 2. Negative 1 and 0. What's the left endpoint? Negative 1. 0 and 1. What's the left endpoint? 0. 1 and 2. What's the left endpoint? 1. 2 and 3. What's the left endpoint? 2. 3 and 4. What's the left endpoint? 3. So I want the function values at the left endpoints now. -2, -1, 0, 1, 2, and 3. Okay, delta x is still 1, and the function values at -2, -1, 0, 1, 2, and 3. I guess I forgot to write the +3 here. All right. So 0, -1.5, 0, +1.5. See, 1, 2. And f of 3 is -1, 0.5, and -1. Okay, so that comes out to be -0.5 this time. Okay, choosing the left endpoints. Okay, then M6, midpoints. So what's the midpoint here? -1.5. Midpoint, -0.5. +0.5. 1.5, 2.5, 3.5. It's the function values at the midpoints. That means the heights. So at -1.5, the height is -1. Then -0.5, -1. Remember, each of these squares is half a unit. So that's also a -1. +0.5, 1. +1.5, 1. 2.5, 1, 2.5, 0. And then 3.5, -0.5. These two cancel these two, but I still have a -0.5. So the answer is -0.5. Okay. So that's it. Let me do the focus thing again so you can see it. And that's that. Okay, I'll go back and look at problem 5, which is very similar. Estimate the integral from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 subintervals. Okay. If you're going from 0 to 10, 5 subintervals. What's my delta x? Hint, you're going from 0 to 10. How long is that? 10. Divided into 5 subintervals. How long is each subinterval? 2. Right? 10 divided by 5 is 2. So the subintervals, smaller intervals, are from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Okay, now I can't show you both at the same time, unfortunately. But this is what we had. Going from 0 to 10, n equals 5, delta x is 2. Here are the subintervals we said. 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Right? 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. We're integrating from 0 to 10. 5 pieces means delta x is 2. So I made a little table here. Left endpoint. What's the left endpoint between 0 and 2? 0. Between 2 and 4, 2. Between 4 and 6, 4. Between 6 and 8, 6. Between 8 and 10, 8. Those are the left endpoints, right? Right endpoints. What's the right endpoint from 0 to 2? 2. What's the right endpoint from 2 to 4? 4. 4 to 6, 6. 6 to 8, 8. 8 to 10, 10. Middle, midpoints. What's the midpoint between 0 and 2? 1. Midpoint between 2 and 4? 3. Midpoint between 4 and 6? 5, 7, 9. Right? So those are the function values. Right, so once again, I want L5, R5, and M5. Okay, my delta x is 2. So if you were to make those rectangles, right, when you go base times height, and so on, remember the heights might actually be depths. All the heights, oh, sorry, all the delta x's are 2. So for all of these, it's going to be 2 times something. 2 times, 2 times, 2 times. And then the function values, that is the heights, if I'm doing L5, then at the left endpoints, 0, 2, 4, 6, 8, the heights are 3, -1, 0, -2, and 2. And again, sorry, I can't really show you both at the same time. Good. Here we go. The heights, 3, -1, 0, -2, +2. Okay, add them all up, 4. R5, the height at the right endpoints. The right points are 2, 4, 6, 8, 10. Okay, -1, 0, -2, 2, 4. -1, 0, -2, +2, +4. So that comes out to be 6. Finally, M5, the height at the midpoints. The midpoints are 1, 3, 5, 7, 9. Here are supposedly the heights, 0, -1, -1, 0, and 3. So the heights at 1, 3, 5, 7, 9. Okay, the heights at 1, 3, 5, 7, and 9. 0, -1, -1, 0, and 3. Comes out to be 2. Okay, so that's it for number 5. Do my focusing thing for you there. Okay, number 7. A table of values of an increasing function is shown. Use the table to find lower and upper estimates for the integral from 10 to 30 of f of x dx. So the integral, assigned area, SIGNED, from 10 to 30. Okay, take a look at the table. What appears to be delta x? What's delta x? 10, 14, 18, 22, 26, 30. Delta x is 4. So it's going to be 4 times something, right? All right. This appears to be an increasing function. As time goes by, the values increase, right? From -12 to -6 to -2, it's getting bigger. All right, lower estimate. So between each pair of numbers, the lower estimate would be to take the smaller number. Okay. So between -12 and -6, the smaller number is -12. From 14 to 18, smaller number is -6. 18 and 22, smaller number is -2. So in this case, the left sum would give me the lower estimate, right? All the way down to 26 to 30, 3 and 8. The smaller number is 3. So I simply take 4 times on each pair, 10 to 14, 14 to 18, 18 to 22, 22 to 26, 26 to 30. I take the smaller number. So it's 4 times the sum of all of these, not counting the 8, because 8's not going to be a lower estimate. So it's 4 times the sum of -12, -6, -2, 1, and 3. So lower sum is delta x. The left endpoints, -12, -6, -2, 1, and 3. Comes out to be -64. Okay. Upper estimate. Now, for each pair, I take the larger number. So -12 and -6, -6 is larger. -6 and -2, -2 is a larger. So this time I take the right endpoint, which means add up -6, -2, 1, 3, and 8, and multiply that by 4. The 4 is a delta x. So the upper sum, 4 times -6, -2, 1, 3, and 8. And it comes out to be about 16. Okay. Okay, so that's how to do that one. Okay, now we have some problems. 9 and 11. Use the midpoint rule with the given value of n to approximate the integral. Round the answer to 4 decimal places. Okay. So let me do number 11. Integral from 0 to 2, x over x plus 1, n equals 5. Okay, integral from 0 to 2, 2 units. Divided into 5 pieces. Okay, so think, what is my delta x? From 0 to 2, chop it up into 5 pieces. How much is my delta x? 2 divided by 5, 2/5 or 0.4. Okay. So this is what I want. I'm going from 0 to 2. Delta x is the length of the interval divided by 5. They told me to chop it up in 5 pieces, 0.4. And you only want the midpoints. So here we go. Starting from 0, count by 0.4s. 0.4, 0.8, 1.2, 1.6, 2. Right? All right. So if they said use the left endpoints, I would pick 0, 0.4, 0.8, 1.2, 1.6. On each smaller interval, on each subinterval, those are the left endpoints. Now, suppose they said pick the right endpoints. Okay, so 0 to 0.4, 0.4. 0.4 to 0.8, the right endpoint is 0.8. 0.8 to 1.2, the right endpoint is 1.2. And then 1.6, and then 2. But in these problems, it said to use the midpoint rule. 9 and 11. So in red, I picked the midpoint on each subinterval. So what's the midpoint of the first subinterval from 0 to 0.4? 0.2. What's the next midpoint between 0.4 and 0.8? 0.6 and 1 and 1.4. And finally, what's midway between 1.6 and 2? 1.8. All right. So my M5 is delta x. Remember, you're doing base times height, base times height, base times height, base times height, base times height. All the bases are the same, 0.4. So you factor it out and just get all the heights. How do I find the heights? It's the function values at the midpoints. So 0.4 times f of 0.2 plus f of 0.6 plus f of 1 plus f of 1.4 plus f of 1.8. If they ask for the left endpoints, I would pick 0, 0.4, 0.8, 1.2, 1.6. If they said pick the right endpoints, 0.4, 0.8, 1.2, 1.6, 2. Okay, so how do I find the heights? Plug into the function. This is the function whose integral we're approximating. Remember, this symbol, integral from 0 to 2 of x over x plus 1 dx, the concept is the exact value under the curve from 0 to 2. Right now, we can't get the exact value. We can only approximate. Okay, so what's f of 0.2? 0.2 divided by 1.2. Plug in 0.6. 0.6 divided by 1.6. Plug in 1. 1 over 1 plus 1, 2. Plug in 1.4. 1.4 over 2.4. plug in 1.8, 1.8 over 2.8. Okay, and again, I won't take up class time to punch it in a calculator. You can do this as well as I can or better. Roughly 0.9071. Okay, so that's it for number 11. And then another one like that was number 9. Zero to 8, sine of radical x, n equals 4. Okay, so what's my delta x? Going from 0 to 8, chop it up into 4 pieces. Delta x is 2, right? Going from 0 to 8. By the way, for all these, they're conveniently going from 0 to 8. You don't have to start at 0. You can start at any number you want. Okay, and in a future section that we're going to do, it's not going to start at 0. It's going to start at something else. So delta x is 2. Okay, so we're finding M4. It asks for midpoints. So 0 to 8, delta x is 2. So 2, 4, 6, 8. The midpoints are 1, 3, 5, 7. So M4 is simply delta x, which is 2, times f of 1 plus f of 3 plus f of 5 plus f of 7. These are the midpoints. So it's 2 times plug in 1, sine of square root of 1 plus sine of square root of 3 plus the sine of the square root of 5 plus the sine of square root of 7. Punch it in your calculator, 6.1820. There we go. All right, so that takes care of those. And go back to problem 1, because I'm jumping out of order purposefully because I want to make sure you see enough of certain type of problem. Then if I cover what I think I need to, then I'll go back and do others. Okay, evaluate the Riemann sum. So what's this Riemann sum stuff? When you chop it up into so many intervals and you go base times height, and so on, that's a Riemann sum. All right, f of x is x minus 1. X is going from -6 to 4, 5 subintervals, and right endpoints. So they only want right endpoints. Okay, so -6 to 4, how far is that? How far is it from -6 to +4? 10. Chop it up into 5 subintervals. So what's my delta x? 2. Right? And they want right endpoints. Here's a quick picture. X minus 1, slope of 1, y-intercept of -1. So crudely something like this. Okay, -1, -2, -3, -4, -5, -6. 1, 2, 3, 4. All right, they said to use right endpoints. So between -6 and -4, which is the right endpoint? -4. Okay, before I said go up until you touch the curve, but now it could be up or down. So I go down till I touch the curve, draw a rectangle. So that's going to be indicated by a negative. -4 to -2. What's the right endpoint? -2. Go down until you touch the graph, draw a rectangle. -2 to 0, right endpoint, 0. Go down, draw a rectangle. So that'll be a negative, that'll be a negative, that'll be a negative. 0 to 2, right endpoint, 2. That one's going to be positive. And then 2 to 4, right endpoint, 4. Go straight up until you touch the curve, draw a negative. So offhand, it looks like there's more negatives than positives, which means I expect the answer to be negative. All right, so think of it as base times height, which in this case is a depth, it's a negative. Base times height, negative. Base times height, negative. Base times height, positive. base times height positive. Well, the bases are all the same. They're all 2. It's always going to be the same. So it's easier to factor out the 2 and just give me the heights. The heights at the right endpoints. So what is this height? Well, you could look at the picture, but it's easier to just plug into the function. -4 minus 1 is -5, right? Then from -4 to -2, what's the right endpoint? -2. -2 minus 1 is -3. -2 to 0, the right endpoint is 0. 0 minus 1 is -1. 0 to 2, right endpoint is 2. 2 minus 1 is 1. Finally, from 2 to 4, the right endpoint is 4. Plug in 4, 4 minus 1 is 3. And add these up, I notice that -3 cancels a +3. I notice that -1 cancels at -1. So all you have is 2 times -5, -10. Just as we anticipated, the answer would be negative. Okay, that's where he goes. Okay, so that takes care of most of these problems at the beginning, or maybe all of the problems at the beginning. So now the problems at the end. So taking care of these. So what's up with 33, 34, 35 to 41? Okay. So 34 is even. Let me show you that one. The graph of G consists of 2 straight lines and a semicircle. Use it to evaluate each integral. Okay, so unfortunately, I can't write and show you at the same time, but maybe we can figure out some areas. Okay. So what is this triangle's area? 1/2 base times height. So 1/2 of 2 times 4, which is 4. It's 4. How about this tiny piece right over here? It's a half. I mean, you can use the formula, but look, that's a whole square, that's half. So this is 1/2. What is the area of this semicircle? Well, the radius is how much? Radius is 2. So the area is 1/2 pi r squared, which is 1/2 pi times 4, or 2 pi. So as an area, that's 2 pi. That semicircle, right? Okay, so again, that triangle on the left, I can't show it to you because I don't have any more hands, but that area is 4. 1/2 of base times height, 1/2 of 2 times 4. 1/2 of 2 is 1, height is 4. Okay, that little piece there between 6 and 7, that's clearly a half of a square, so that's a half. And the semicircle I claim is 2 pi. The formula for the area of a circle is pi r squared. You have half a circle, so it's 1/2 pi times r squared. R squared is 2 squared of 4, 2 pi. Okay, so what's the answer to A? Then you go from 0 to 2. What's the signed area under the curve? It's 4, right? So this is definitely 4. How about B? Integral from 2 to 6. Right? The area is 2 pi, but it's all below the x-axis. -2 pi. Okay, so remember the integral gives a signed area, SIGNED, or a net area. Okay, the area is 2 pi. We're not going to stray from our rule of saying area is always positive. Right, so if I took that semicircular region and said, what's the area? If I had to paint it, it's 2 pi. There's no such thing as an area of -2 pi, but we can claim an integral is a negative, right? So the integral from 2 to 6 is -2 pi. Exact value, not approximately. And finally, C, integral from 0 to 7. Okay, so I take everything that's above, which is 4.5, and I subtract the part that's below, which is 2 pi. Okay, so I'm going to say 4.5 minus 2 pi is the answer to C. Okay. Okay, so that's how you do 34. You can do 33, which is similar. And you got the answer in the back of the book, and it's all straight lines. So you know how to find areas of rectangles, triangles, and so forth, right? So there isn't any curve in 33, so I'll let you figure that one on your own. Okay, then just about done. A few problems at the end. Evaluate the integral by interpreting in terms of areas. So that means we're not going to chop it up into so many pieces. We can find the exact value this time. Exact values of these. Okay, and by the way, yeah, we already did 41 yesterday. The answer is 0, right? Integrate from 1 to 1. There's nothing there. So if there's nothing there, the integral is 0. Okay, so how do you do something like 35? Integral from -1 to 2 of 1 minus x dx. Integral from -1 to 2 of 1 minus x dx. Okay, we know it's a line. 1 minus x is a line. So if I draw a line, the area bounded by the graph and the curve should give me just a bunch of triangles, and I know how to find areas of triangles, right? So here we go. Okay, we're going from -1 to 2. So I drew myself a little picture here. Slope is -1, y-intercept is 1. See, when you plug in -1, 1 minus a -1 is 2. Plug in 0, 1 minus 0 is 1. Plug in 1, 1 minus 1 is 0. Plug in 2, 1 minus 2 is -1. So it looks like this. So the integral will be this area minus this area, right? Because this region is above the x-axis. This is below the x-axis. So the integral, the true value now, not an approximation. I'm not chopping it up into so many pieces. I can find the exact value of the integral. Okay, so what is the area of this triangle? 1/2 base times height. Base is 2, height is 2. 1/2 of 2 times 2 is 2. So I said A1 is 2, area 1 is 2. What is A2? Well, this tiny piece over here is 1/2 a unit. It's 1/2 base times height, 1/2 of 1 times 1, 1/2. Therefore, what's the value of the integral? The integral is a signed area, SIGNED, where the part that's above the x-axis is counted as positive, so +2. The part that's below the x-axis is counted as a negative, so 2 minus 1/2. Final answer is 1.5. And there we go. Okay, 37. Integral from -3 to 0 of 1 plus radical 9 minus x squared dx. So first you have to think about the graph of this. Let me consider square root of 9 minus x squared. So I'm taking a quick time out. Just look at y equals radical 9 minus x squared. If I square both sides, y squared equals 9 minus x squared. Add x squared plus y squared equals 9. Oh, that's a circle with the center of the origin, radius of 3. So the entire circle would look like this. Okay. But if I say y equals, and a square root isn't going to be negative. So there's no negative part. And the original problem says only go from -3 to 0. So I only have this part right here, second quadrant portion. Okay, so one more time. Y equals square root of 9 minus x squared. Ignore the 1 temporarily. I know it's there. Square root of 9 minus x squared. A little bit of algebra. X squared plus y squared equals 9. Circle center of the origin, radius 3. So imagine you have the whole circle. Okay. Now, if you have the bottom part, that would be negative radical 9 minus x squared. You have the top half, so that's positive radical 9 minus x squared. And then in the original problem, they said you want the integral from -3 to 0. So you're only taking the second quadrant part. So here's -3, 0, here's 0, 3. So this is the graph of radical 9 minus x squared. Now, what's the effect of the +1? Move this graph up 1 unit. So -3, 0, -3, 1, 0, 3, 0, 4. So here's my picture. So the integral from -3 to 0 of this function is this area, which I can chop up into a quarter circle and a rectangle. Okay, so that's my hint for that. I let you finish the rest of that on your own, but that's easy. That's base times height. That's 1/4 of pi r squared. Okay, so you should be able to figure that out. Okay, I think I'm done with this page, so let me do my focus thing again. Give you that. Well, I'll give you this also. I did it before. 5.1, number 5. Involves a picture, so there's the picture for that. And all of this. And this. Okay. And 39, then we're done. I think I literally may have done them all. 39, -4 to 3 of absolute value of a half x dx. All right, now you could use your rules of transformations of the absolute value function. You know, the absolute value is V-shaped. And take half of that, or you can just make a little mini table. Thought it was easier just to make a little mini table here. Go from -4 to 3. So -4 gives me 2. -3 gives me 1.5. Remember, absolute value means it isn't going to come out to be negative. -2 gives me 1. -1 gives me 0.5. 0 gives me 0. 1 gives me 0.5. 2 gives me 1. And 3 gives me 1.5. Okay, so in any event, here is roughly the picture. Key points, -4, 2, 0, 0, 3, 1.5. Okay. All right, so I got a triangle here, triangle here. So A1, area 1, 1/2 base times height. So 1/2 of 4 times 2, 4. A2, 1/2 base times height. 1/2 of 3 times 1.5, 2.25. Add them up and have my answer. So integral from -4 to 3 of absolute value of 1/2 x dx. But this is an exact value now. We don't have to approximate. When we have circular regions or rectangles or triangles, we know how to find those areas. It's when we have a curve in general, we don't know how to do it, at least not yet. So that's going to be 4 plus 2.25. It's all positive because it's all above the x-axis. So 4 plus 2.25. Final answer is 6.25. And there we go. Do my focus thing again. All right, so I think I'm done with the section. Okay, we only have a few minutes left. I'll just give you an introduction to the next section. It will just save me time for next time, and then we'll quit. So schedule-wise, we are up to here. Okay, so I wasn't supposed to start 5.3 until tomorrow, and I still have all these buffer days here. Okay, so that's fine. Okay, so we're down to just 3 more sections. 5.3, there's a lot going on in 5.3 though. Okay, so let me just introduce a little bit of it. 5.3, page 392, something called the fundamental theorem of calculus. So we have this strange new function, sort of like an area function. Number one, g of x is the integral from a to x of f of t dt. Now, a is a constant, x is a variable. Okay, so maybe I'll put that down here. This is constant. This is variable. Okay, constant on the bottom, variable on the top. G of x is the integral from a to x. And since I've already used x, I'm not supposed to use f of x dx. So they just switch over to f of t dt. Okay, so a mathematical principle is once you've already used up a letter, you're not supposed to reuse it in the same problem to mean something different. So since they've already used up the letter x, that's why they switch over to f of t dt. Here's a picture. Okay, here's a, it's fixed, but x moves. If I move x around, you can see I have an area function, right? I have a different amount of area. So right here, that looks like, pretend it's 5 units. Okay, if I move x to the left, it looks like there's going to be less area. If I move x to the right, there'll be more area. If I move x to line up with a, I get 0, right? So it is a function. You give me a different x, I come back with a different area function, right? So that's why this is a legitimate function. It's kind of a weird function. It's an area function. But g of x is the integral from a to x of f of t dt. So imagine a is fixed. You don't move it. But x can move back and forth. As I move x, I get a different area, right? Move it this way, it looks like there's less area. Move it this way, I get more area. And I say area, I'm implying it's positive. It doesn't have to be. Again, the picture could be like this, right? Where if I keep going this way, you'd actually be picking up negative values of the integral because the area is negative. Okay, and then I'll just show you this and then I'll quit. On page 393, here's a function. G of 1 is 1. That area is 1. G of 2 is 3. The area is 3. G of 3 is approximately 4.3. They can only say approximately because it's curved now. Here they say G of 4 is 3 because you've got positives and negatives, right? So you give me a number, I have a different value of the integral. That's what's going on there. Okay, and that's as much as I want to talk about today. Okay, so I'll stop. Let me check the chat. Okay, anybody have any questions? Let me know. Or if you join late, go ahead and put in the chat. So I see Dominique got you, Caio, Antonio, okay, got you. Okay, anybody else with a question? Otherwise, we're done for the day. All right, I don't see or hear anything. So that's it, folks. All right, so have a good day. We'll see everybody tomorrow. Okay, bye, everybody.